Okay, the next interesting topic in stats would be curve fitting, guys. I can just tell you in a minute you can finish off solving the problem provided you have a calculator if you know how to write the normal equations. Curve fitting. Okay. What exactly is curve fitting is fitting a curve of our choice is curve fitting. Okay. Fitting a curve of our choice. Choice. Okay. You will be given a data xi, yi. Okay. For I is equal to 1 to n. If you want to write that in a table, it will consume little more space. That's why I've written like this from I is equal to 1 to n. Okay. So if you want to of our choice to the data this, you want to fit, suppose I'll just directly come to the topic so that in the short video you learn many things. Fitting a straight line, fitting a straight line. Okay, of the form y is equal to a plus bx or ax plus b, depending on the equation, I'll be writing certain things. Okay. Now, fitting a straight line. How do if I want to fit a straight line of the form y is equal to a plus bx, I already have the values of x and y in the table, but what are the unknowns are a and b. So two unknowns are there. To find the two unknowns, I'll be needing two equations. See how I will write. There'll be something called normal equations always, normal equations. There's a derivation using principle of least squares. I'm not going into the details of it because this is just a shortcut video, right? So what you do, write the normal equation, that is summation y is equal to sum of a's n times. Data has n values now. So sum of a n times would be na plus b summation x. X values are there. Depending on the data, I'll be summing up. That's why summation is as it is. I can just write I is equal to 1 to n. Here also I is equal to 1 to n and all those things. Summation I is equal to 1 to n. The next normal equation before writing, just remember that it's as if you are multiplying the above equation with x. xy, this is equal to a. No more n will be there. Summation x will come. Of course, all suffix i's will be there because the summation has some range from I is equal to 1 to n. A into xi plus b into summation I is equal to 1 to n xi square. It's as if I have multiplied the above equation with a x. It is like that. Okay. Yeah. Just be careful when you are writing summation. The first equation, usually people miss this na. Similarly, be careful while writing the second normal equation. Usually people will write na, they will write and also put summation xi because it's shortcut. You need to think little smarter and then answer. Okay. Now, next I'll come to the next one. Fitting the next curve. Okay. Fitting y is equal to a e power bx. This would be called an exponential curve, guys. If you know linear, I mean how to fit a straight line, all the things will fall in line. Okay. What that is once you know one thing, we'll try to correlate everything to that only. Now, whenever I have powers in x and all, when you cannot handle or when you want to make things similar look like linear, what I'll do is I'll apply log on both sides. Apply log on both sides to the above equation, So what happens? Summation y, no, I'm sorry, log I'm applying, right? Log y is equal to, I'll be applying all the rules of log a b, log a plus log b, log a power n into log a. Okay. So log a plus bx log e base e. Log e base e value is 1 anyways. Okay, so this value would vanish off to be 1. Now I'll rewrite this equation. Just see here, guys. Capital Y, this is equal to capital A plus capital B into capital X. Anyway, this is 1. I don't consider. You can ask, what is capital Y? It is nothing but log Y base E. What is capital A? It is log A base E. Okay. Now, ma'am, when small b is b only, why are you writing capital? Just to maintain that rhythm. Okay, when I am putting everything capital, some things in capital, something in small, doesn't sound good. So to maintain that rhythm or uniformity, I'm using this. Now, clearly I can see that this is a straight line equation kind, looking like a straight line equation. So I will write the normal equations also of the straight line only. Normal equations also in the form of the straight line. Looking at the equation, you write. Don't worry whether it is y is equal to ax plus b or a plus bx. Okay. Looking at the equation only, write the normal equations. Summation y, this is equal to again na plus b summation x. Okay. Summation xy, I am multiplying the above equation with x. It is like that. A summation x plus b summation x square. These equations look complicated. What do I do with these equations? Don't worry, guys. Already I have the data. See here, I have this table. X values are there, Y values are there. Sum of all X values will be summation X. Sum of all Y values will be summation Y. Now, if I multiply both and take the sum, then it will be summation XY. If I square X values and take the sum, it is summation X squared. So, these normal equations reduce to two equations, two unknowns. Okay, solving which I'll be getting, if I solve these two equations, I'll be getting the values of A and B. That's it. Okay. Don't think I have left there halfway through. Here also, I'll be solving these equations for capital A and capital B. Okay. Once I get capital A and capital B, actually my equation was not y is equal to capital A plus bx. Actually, my equation was small y is equal to a small a e power bx. Okay. So, if I get capital A, to get small a, now what I have taken capital A is log small a I have taken. Okay. So if I want the value of small a, I have to apply anti-log on both sides. Or e power a is equal to small a is what I will be getting. Okay. Now for b, what the assumption about b? B is just b only. Only for the uniformity of all capital letters, I have taken small b to be capital B. Once I find capital A and capital B from this, I'll find out small a and small b from this, because our question is in terms of small a and small b and small x and small y, and not in terms of capital X and capital Y. I have chosen them only for my comfort. Okay. Next, just to see one more I will do, and I will close this video. What that is to fit y is equal to a plus bx plus cx square. A parabola, if I have to fit. Looking at it, write the normal equations, guys. Okay. Because this shortcut, don't ask me the reasons. Of course, the reason behind it is the principle of least squares. Once you go with principle of least squares, you get the same thing. Okay. Now, na plus b summation x plus c summation x square. Okay. Next, multiply with x. A summation x. Be careful with na and a summation x. Okay, that's the caution I will tell you. Execute. Next, summation x square y. This is equal to a summation x square plus b summation x cube plus c summation x power 4. What do? I construct a table, find all these values, take their sum, and then finally substitute in this. I'll be having three equations, three unknowns. I'll be solving for small a, small b, and small c. Again, I'll tell you, please do carry your calculators. That will make your job simple. Even for calculating distributions, do carry your calculators if you have upgraded versions of the calculators. Okay. I'll do some more things in the next video.